This is AS Maths 2020 paper 2, so this is the pure and stats section. Identify the expression below that's equivalent to this. If you've got a negative power, it's just a reciprocal, so this is 1 over e to the power of 2 over 5. Just do the fifth root of this. Fifth root of this is just 1, and then the fifth root of this is just e to the fifth root, and then you want to square it. 1 squared is 2, and then this is just that. I mean, you should know that. Just one thing to point out here, it doesn't matter if this square to the power of 2 here is inside or on the outside. It means the exact same thing. So if you do that and then you'll get the square out here, it's the same thing. So this is your answer. You get given this and that. Determine which statement below fully describes the possible values of y. Okay. You can just go through them and then just see which one's likely. First of all, the first one's just definitely not correct. If x is going to be less than -1, so you'll get -50. 1 over -50 is not going to give you a number that's like -700 or -7 trillion or just whatever. Okay, so if this value is going to increase, if you just ignore the negative, it's going to increase to like 70 or 90. The largest value y can be is -1. No, it can't even equal -1 because this is not even inequality. Okay. The largest, first of all, what can we say? That y has to be this one here. Okay, because if you let this be some value that's smaller than -1, so -0.000, -1.0001, this will be close. Y will be close to -1, but it won't actually be -1. It'll always be slightly greater than it. And it can never equal 0 because there's no value that x can take which gives you y equals 0 here, because if you just graph this, you'll see that it asymptotes at that point, at that line, sorry. Anyways, yeah. Question 3, find the second derivative. Okay, just make this look a bit easier. This is 2x to the -1, and then this is -1/4x. Get that? Differentiate this. This is 12x cubed minus 2x to the power of -2. And then this is just -1/4. This is to the power of -2 because -1 take away -1 is just -2. You should know that. Same thing again. This is going to be 36x to the power of 2 plus 4x to the -3. -2 multiplied by -2 is positive 4x to the -2 minus 1. So that's -3. And that's your answer. Find the solutions to this. We've got the easiest thing that you can do is just turn this into a sine squared. So you can say this is equal to 1 minus sine squared x, and then just collect like terms. So 9 take away 1 is just 8, and then -6 take away 1 is -7. Anyways, you'll get this. You can just do a substitution. So you can say that sine x equals u, or I don't know, like z or whatever you want. I couldn't be bothered. I've just factorized it to get this. So either sine x equals -1/8 or sine x equals 0. If you start with just the easy one, so sine x equals 1, then you've got x equals 90 degrees. And then the other solution is, actually there's no other solution within that range, so x equals 90 degrees is the only one. And then for this one, you'll get x equals 187.2 degrees. Okay. I don't think that's actually the first solution you'll get. You'll get something else, but if you do 180 take away whatever you got, and then you'll get this. Okay, and then this is actually just a little bit over our range. So you can take away 360 from it to get 172.8. So that'll barely get us inside of it. We can take away 360 or add it as many times as we want because of the periodicity of the sine graph. That's a hard word to say. Anyways, you get that. Joseph expanding this and sending powers back. He said that the coefficient of the fourth term is this. Be careful here. If you're going to use the binomial expansion formula, right, just be careful. This is going to be n minus r here, and then this is going to be r if it's ascending. Usually I use it so that it's r here and then n minus r there, because usually it doesn't matter, because when I'm doing it the other way, I'm usually going in descending powers of x. But if you're ascending, then just be careful to swap these two around. If you're not fully comfortable with that, then maybe just use Pascal's triangle and then expand it all out. But anyways, yeah, so you'll get this. So you don't. 7 choose 3 of a to the power of n minus r, and then b to the power of r, where n is 7 and then r is 3. Anyways, if you do all this, you'll get minus 15,120x cubed. So yeah, that's just one thing I wanted to say here. Put it here. I've said that usually I use it like this, and that's only if you're going to be descending. Okay, I don't want to be descending here, I want to be ascending, so I've just swapped these two around. Makes no difference, as long as the powers add up to this number here, which is 7. Oh, wait a minute, did I even answer the question? Explain the teacher's comment. No, I didn't. The teacher's correct because it's not positive 15,120, it's minus 15,120. A circle has this equation, find the center. Just put the x's together, put the y's together, and then bring the 71 to the other side, and just you'll get this. And then complete the square on this side, so this is x plus 5 all squared minus 25, then this is y minus 2 all squared minus 4. You'll get that. I'm not even going to bother with these two. You can see that the center is minus 5 and 2. Hence, find the equation of the tangent to the circle at this point. Okay, now I actually have to bother with this. Put this in your calculator, bring it to that side, you'll get 100. R squared equals 100, so r must equal 10. There are a few ways to do this question. I've just put this like this and then this like that, because when I was doing this question I was actually like a bit tired and I couldn't be bothered to do it properly. And I know a trick to do this just really quickly, and that is if you write this out as like this. So say if this was x squared, you do x multiplied by x, or if it's x plus 5, you do x plus 5 multiplied by x plus 5. The trick is if you replace one of the x values here with this point here, with the x value of the point, and then one of the y values with the y value of the point to get this. That's just the equation of the tangent. Okay, I know it doesn't look like it, but it is. If you just expand it out, you'll get this, and then just rearrange it slightly, you'll get that. And that's your answer. I mean, that's completely fine. Okay, you could do it the other way if you want, where you find the gradient of the radius and then the gradient of the tangent, which is the negative reciprocal and whatnot. I'm not going to lie, I'm probably not going to get any marks for this, because the examiner probably won't know what I've done. But, you know, the entire point is that you get this answer here. In a test, by the way, can I say, if it's just like, if it's say like your mocks, actually no, maybe they do it for your mocks. Maybe if it's just like a random test that they're giving you in class, go ahead and use this method if you really want to. But if it's your actual exam, maybe just go with a slightly long-winded method, just so your examiner can actually follow, because it's a bit risky getting things sent to the senior, to the head examiner, because you don't want to feel worried about your test because you've just used this goofy method. Anyways, question 7. The population in a country was this, 1989. It grew exponentially to reach 6 million 30 years later. Okay, so and we want to estimate the population 30 years after that, if the exponential growth remains unchanged. Okay, so if we find what the ratio is between this and this, so if you just say it increases by an amount x, you can say that 3.6x equals 6. Okay, and then rearrange for x, or you could just do the ratio if you wanted to. Anyways, you'll get 5 over 3. So if you do this multiplied by 5 over 3, you'll get 6. And then if you do 6 multiplied by 5 over 3, you'll get what the population is at this point here. Anyways, you'll get 10 here, but just be careful. Everything here is in million, so this is 10 million, not 10 people. Using y equals 2 to the power of 2x as a substitution, show that this can be written as that. This is 2 to the power of 4x. Okay, and then this here, you can write this as 2 to the power of 2x multiplied by 2 to the power of 3. Because when you've got the same base, you can just add the powers. So, it's fine to write this like this. This here is going to be y, and then this here is going to be y squared. If you just square this on both sides, you'll get 2 multiplied by 2, so that's 4x. Okay, so that's y squared, that's y. This is 8, and then this is minus 9. Just collect them together, you get this. And show that the equation this has x equals log base 2 of 3 as its only solution. We solved this. Just remember our substitution, that was 2 to the power of 2x. Factorize this, you'll get that, y equals 9, y equals minus 1. So 2 to the power of 2x equals that, or 2 to the power of 2x equals that. The next step would actually be doing, is log base 2 on both sides to get rid of this 2 here and this 1 here. But you can't do a log for negative number, so this is not a valid solution. So cross out that. This is the only possible solution. Log base 2 on both sides, you'll get that. Divide by 2, so you've got a half here. Bring the half up here to this power. And then 9 to the power of a half is just 3. And that's the only solution. I think you actually do have to put a comment. I just couldn't be bothered to write it down. Just write down what I was saying, and you'll get the marks. Find this. I don't know why they've actually given you this question at question 9. But paper 1 had a much more difficult question than this with question 8, so I'm quite surprised that they've given you this. Anyways, so this is just x to the power of 1 increased by 1, that's x squared, and then over 2. So 4x squared over 2, that's 2x squared. And then this is going to be minus a quarter x to the power of 4 plus c. Evaluate this. Now, what I did was, I just said to myself, well, first of all, I've just gotten rid of this plus c, because when you're going to be doing this, the c's will cancel out because you'll have plus c minus c. So I've just gotten rid of it. It makes no difference. And then just put in your limits. So plug in x equals 2 here, and then subtract it from when x equals minus 2. You'll get this, which is equal to 0. Okay. Using a sketch, explain why the integral implied does not give the area enclosed between the curve and the x-axis. This is I've just copied this from the mark scheme. The reason why it looks like this, I'm hoping you can tell, is because this part under the x-axis will give a negative result, and then this part above it will give a positive result. And these have cancelled each other out perfectly. So this here will look almost exactly like, it'll look exactly like that, but it's just being flipped on the x-axis. And then also on the y-axis, actually. Okay, or it's just being rotated, actually. But anyways, what you need to say is the area under the x-axis cancels the area above it, because the area below is a negative. Find the area enclosed between this and the x-axis. If you're smart about this, you can just say that, okay, so if you just plug in 2, okay, that was our upper limit, you'll get 4. Now, if you know that one of the areas is 4, then the other one has to also be 4, because for them to perfectly cancel out, the other one has to be minus 4. And you want to take the absolute value of it because it was below the x-axis. So you do 4 multiplied 4, add that other 4. In other words, 4 multiplied by 2 to get 8. A curve has this gradient function and the turning point minus 1, 1. Find the coordinates of the other turning point of the curve. Okay, so if it has a turning point, it's a stationary point, so the gradient equals 0. So make this equal to 0 to get that. And we're saying that when x equals minus 1, this all equals 0. So plug in minus 1. Just rearrange for c, which is minus 15. Plug it back into there to get this. And then the coordinates of the other turning point, this equals 0. Divide by 3 on both sides to get this. Factorize it to get this. You'll tell that you've gone that you're gone down the right path here, because you'll have that one of the turning points is x equals minus 1, and that's the one that we already have. So you can just ignore this. So the other one is just x equals 5. Okay, I've just written this out. X equals 5 there. Just remember that. If you integrate this to get what y equals, so what just the curve is, okay, you'll get x cubed minus 6x squared minus 15x plus k, so the constant of integration. I've used k here because I used c last time. Well, it made me use c actually. Anyway, so when x equals minus 1, we know that y equals 1. That's just some random point on the curve. So plug that in to get what k equals. It's minus 7. Plug that back into there to get this. And then when x equals 5, what does y equal? Put this into your calculator, you get minus 107, and that's your turning point. Find the set of values of x for which y is increasing. If it's increasing, the first derivative is greater than 0. Divide by 3 of both sides to get this. We already solved this. This is x equals 5, x equals minus 1. If we want to be greater than 0, x is going to be greater than 5, or it's going to be less than minus 1. A fire crew is tackling a grass fire, shooting the water jet like this. find the value of A, the coordinates of the point A are this. Just plug in x equals A and then y equals 0 to get what A equals. You'll get this. You can factorize this. Honestly, just don't bother. You have a calculator, put it in, you'll get A equals 6 or 34. Now, A doesn't equal 34, and the reason why is because if this is an upside down parabola, because it's a minus x squared, then this is going to look something like this, right? And you can just see by inspection that A must equal 6, because A equals 34 will be when it's already turned around and it's going to be going back down, right? And you might just say that it has to be A equals 6 because it doesn't make sense that they'd shoot the water jet 34 meters away. Actually, no, I don't think that's a very good way to think about it. The better way is just what I said originally, where if it's an upside down parabola, then the point further to the right has to be the larger one. So it's not this one, it's just A equals 6. Find the horizontal distance from A to the point where the jet hits the ground. It hits the ground at A equals 34, because we said that's when it goes back around. Okay, so what's the distance from A, which is 6, to 34? 34 take away 6. Is that it? Okay, I've actually just not done the question properly. Just do 34 take away 6, so you'll get 28 as your answer. Yeah, from A, yeah. So I've actually done that wrong. Apologies for that. I must have just not read it properly. Yeah, just do 34 take away 6, which is 28. Calculate the maximum vertical height reached by the jet. It's got a stationary point there. You could differentiate and solve for it. I couldn't be bothered. In the max scheme, it'll show that you need to differentiate for it, but you don't actually have to, because if this is an upside down parabola, if you find the mean of the points here and then divide it by 2, so if you find the middle point, that x value will correspond to the turning point. So if you do 6 add 34, which is 40, and then you divide by 2 to get to 20, that'll be the middle between those 2 points. Okay, and at that middle point, if you go up, you'll find where it turns. So plug in x equals 20 into that to get what y equals. You'll get 2.45. A vertical wall is located 11 meters horizontally from A in the direction of the jet. The height of the wall is 2.3 meters. Okay, so if the wall is like here, height of 2.3 meters, the distance from here to here is 11. Just be careful, this is the point 6, so this is not 11 from here. Okay, so this distance from here to here is 5. Sorry, from here to here is 5, not 11. No, sorry, yeah, it is. Yeah, the distance here is 11. Okay, and then this point here is just going to be 6 plus 11, which is 18, which is 17. Sorry. So it has this wall has x value 17, and we need to find what the y value is at that point of the actual curve. Okay, so how high does the water get at the wall? Well, it gets this high, and that's greater than the height of the wall, so it doesn't actually touch it. Oh yeah, and assume no air resistance. I've said this because if there was air resistance, it'd be pushing back on the water, which means it'd actually curve down much sooner than you expected it to, so it would actually hit the wall, because these two numbers are actually quite close to each other. This is the stats part. We've got an anomalous result. Which one is it? Just be careful. Just look for all of them. You might say it could be D possibly. No, look for A. It's all the way up here on the side. Random variable x is such that this x is distributed as B. The standard deviation of x is 4. First of all, the standard deviation is just the square root of the variance, because variance is just standard deviation squared. And so if we find the variance, it's just MPQ, where Q is 1 minus P, and P is this. So you do this multiplied by that, multiplied by 2/3, and that equals standard deviation squared. So 2/9 n equals 16, because 2/3 multiplied by 1/3 is 2/9, 2/9 multiplied by n is 2/9 n, and then divide by 2 on both sides to get this, multiply by 9 to get n equals 72, and so yeah, that's it. It's 16 here because 4 squared is 16. This is just a lot of waffle, I can't lie, but there's this company with a bunch of employees in a bunch of stores, and they want to sample some of them. So give one disadvantage of using method A compared with using method B. Method A, choose 100 people who work at the largest store. Method B, choose one person at random from each of the 100 stores. Now, method A is biased, all right, because if you're just looking at people from the largest store, they're going to have different opinions from the people at the other 99 stores. So it's not really fair just to pick only from one store, right? Because all those people might have slightly similar opinions compared to other people at different stores. So method A is biased, whereas B is not. Or you could technically B might still be a little bit biased because if you're only checking one person, but it's less biased. Give one advantage of using method B compared with using method C. Choose one person. We've already read this. List all the employees in alphabetical order and assign each number from 1 to 5,200. Choose a random number between 1 and 52. Choose this person and every 52nd person on the list thereafter. The thing is, if you're using method C, you don't actually know how. First of all, you don't actually know how many people are working across say 100 stores. So if you have like 32 people, if you have like 30 people working at a few stores, and you're choosing every 49th person, because say you just choose a random number and you get 49, you could just miss everybody from that store or from those stores, right? So method C, you might miss out some people, whereas method B, you're guaranteed to go through every single store. Identify this method of sampling using C. This is just systematic sampling. It's not stratified because you're not actually filtering out the data. That's how I like to think about it. So this is systematic. Give a reason why method C does not provide a random sample. It's because I've already explained it last time, but it negates the possibility of some people being chosen. That's what I've said here. Because as I've already explained, if you say you have 30 people at one store and you choose say the random number to be 50, you could just miss out some people. So it's not random if you're going to be just missing out people completely. This is just from the formula booklet, by the way. A random sample of CO2 emissions selected from the large data set, find the standard deviation. This is the formula that you get given in your book. If you find the mean of all of this, by the way, you can do this all in your calculator, it saves you so much time, but you get 45.4. Just plug it in like this, you'll get 22.9, where x1 and then x2 and then x3, x4, all the way to the end. The environmentalist claims that the average CO2 emissions from 2002 and 2016 combined is 145.8. If you sum these two together and then divide them by 2, you do get 145.8. But the problem is, if you revised your large data set, you'll know that the sample was much larger in 2016 compared to 2002. And so if you don't have like this same sample size across both of them, you're not going to have a very accurate mean. So you can just say that. A mathematical puzzle is published every day in a newspaper. Over a long period of time, Paula is able to solve the puzzle quickly 60% of the time. For a random chosen 14-day period, find the probability that Paula correctly solves exactly 8 puzzles. Okay, so she could just solve them for 8 days continuously, right? So 0.6 to the power of 8. So the first 8 consecutive days, she just solves all of them. And then the other 6 days, she just doesn't solve them properly. So that the probability of not solving it correctly is 0.4. And that's to the power of 6. So that's the other days. Now there's actually a few things that could happen. Because first of all, she could solve it on the last 8 days. She could solve them correctly on the last 8 days consecutively, but not the first 6. Or she might solve them for the first 2 days and then get them wrong for the next 3 days, and then get them wrong for the next few days and whatnot. But basically, you can arrange this multiple ways. The number of ways that you can arrange it is 14, choose 8. Okay? Hopefully that makes sense. You should know how to use this. I mean, you'll have been taught it, hopefully. But what are the different number of ways you can arrange the 0.6 if you like drew out? So if you had, say, day 1, day 2, day 3, all the way up to 14, how many number of ways can you arrange the 0.6 if you have 8 of them? Okay, that would be 14 choose 8 ways. And if you multiply that by this probability here, you'll get 0.207, which is your answer. Paula correctly solves at least 7, but not more than 11. Okay, so first of all, if you look at the probability that she solves less than 11, Okay, what is that probability? But the problem is with that one is that you've also included her solving at least 6 or 5 or 4 or 3 or 2. Okay, so you want to subtract the probability that she solved at least 6 or 7, at least 6 or lower. Okay, this is always an inequality sign here when you're looking at probabilities, so just always include that. But yeah, so probability that is less than 11, including 1, 2, 3, 4, 5, 6, and then we include this part here to exclude 1, 2, 3, 4, 5, 6. Just to be clear, this is what we're actually looking at because across 14 days, and then the probability is 0.6. Okay, put this into your calculator, you'll get this as your answer. State one assumption that is necessary for the distribution used in part A to be valid. Well, it's that each event is independent. This is almost always the answer when you're looking at binomial distribution, so just jot it down. You've got a spinner, show that what's the probability of getting 1? 360 degrees in a circle. You should know this. You're like 17 years old right now. So just do 100 over 360, which is 5 over 18. Complete this. Okay, so what's the probability of getting 2? So that's 60 degrees here and then 90. So 60 plus 90 is 150 over 360. And you simplify that down to 5 over 12. And then 3 here. You've got this 45 degrees here, and then you've got this, whatever this is. This will be 35 degrees, because if you do this, add this, add this, add this, add this, that's 325 degrees. 360 take away 325 is 35 degrees. So you do 35 plus 45, which is 80, and then 80 out of 360, which is just 2 over 9. And then you don't want to put a 4 here, because first of all, you can't get a 4. 4 is just not on here. So you have to go to the next one, which is 5, and that's 30 out of 360, which is just 1 over 12. A bag contains 7 blue discs, 4 red discs, and 1 yellow disc. 2 discs are drawn at random without replacement. Found the probability that exactly one of the discs is blue. Okay, so the probability of getting blue is 7 out of 12. And then the probability of not getting a blue is 5 over 12. So you could get blue the first time and not blue the second time, while obviously decreasing this bottom number by 1, because if you've taken 1 out, the total number in the bag decreases by 1. And then this equals 35 over 132. But you could also just not get blue the first time and then get blue the second time. And that's also 35 over 132. And then if you add these two together, because it's this or that, so you're adding them, you get 35 over 66. Bag A contains 7 blue, 4 red, and 1 yellow. Bag B contains 3 blue and 6 red. You take 1 from bag A and you place it in bag B, and then you're taking 1 from bag B, and you want to see what's the probability of this one being red. Okay. The first possibility is if you take a red from A and put it in B. So put a red in B. What's the probability of this? So first of all, 12 possibilities here, and that's 4 out of 12. So the probability that you'll get a red from this one is 4 out of 12. And then now the probability of getting a red out of this one, this 6 increases by 1 to 7. And 7 plus 3 is 10. So it's 4 out of 12 plus 7 multiplied by 7 out of 10. Okay, and then we'll just ignore that for now. And then the probability, and then this is just 7 over 30. Don't put a red in B. So say that you don't get a red from here. So you instead get either a blue or a yellow. So the probability of not getting a red is just going to be 8 over 12. Okay, and then that means the probability of getting a red in bag B. This is still going to be 6 because you've not increased this one, because you've either gotten a blue or a yellow. Okay, but whichever one you get, the total number increases by 1. So this is going to be 6 divided by, and then you've got 9 here, but then plus the one that you've added in. Okay, so say 8 over 12 plus multiplied by 6 over 10, which is 2/5. Add these two together, you'll get 19 over 30. It is known from historical data that 15% of the residents of a town buy the local weekly newspaper. I'm actually just going to skip through most of this. 15% buy this local newspaper. Okay, they've got a sample of 50 people, and only 3 of them actually buy that paper. And then we want to investigate the probability that it's not actually 15%. So H naught, the null hypothesis, is just there is equal to 15% or 0.15, and then H1, so the alternative hypothesis, is that it's not that because it's changed. So this is a two-tailed test. We can say X is the number of people who bought local news, and then we can distribute that under the null hypothesis with a sample size 50, and then the probability is 0.15. Okay, and first of all, how do we know if we want to check the upper tail or the lower tail? Well, one way that you can do it is that the mean of these two is just 50 multiplied by 0.15. It's just NP. So we can say that mu is NP, which is 50 multiplied by 0.15, which is 7.5. And then if we compare that to the actual number of people in the sample which did get local news, you'll see that this is bigger. Okay, or yeah, the number of people in the sample is less than the mean. So we've gotten less than we have expected. So we want to check that the probability has actually decreased. Okay, so we're checking that X is less than or equal to 3. Always an equal sign, remember. Put this in your calculator, you'll get 0.046. And compare that to your significance level. This is 0.05. But just be careful, remember, this is a two-tailed test. So, the sum of the areas of the two tails will be 0.05. And if you check in one tail, it's going to be half of that, which is 0.025. And you compare that to that, this is bigger. Okay, so we failed to reject H0. So in other words, you accept H0 and then you reject the alternative hypothesis because there's insufficient evidence to claim that it's changed significantly. That's the entire paper. Thank you for watching.